Hello friends, so today we are going to discuss a question from JEE Advanced 2025 paper 1, and particularly this question maximum student has many doubts. Okay, so actually this question is asked from the calculus chapter. Question says that a function f is defined from R to R, means a real number. Function is defined such in this way: when x not equal to 0, function is this; when x equal to 0, fx is 2. क्वेश्चन सेज द व्हिच ऑफ द फॉलोइंग स्टेटमेंट इज ट्रू. क्वेश्चन में ट्रू पूछा है, कौन सा ऑप्शन इसमें ट्रू होगा. पहला ऑप्शन दिया हुआ है द फंक्शन एफ इज नॉट डिफरेंशिएबल एट एक्स इक्वल टू 0. मीन्स वी ओनली चेक द फंक्शन इज differentiable or not at x equal to 0. So what is the rule of the differentiability at any point x equal to a? That means if this limit extends to 0, fx minus f0 divided by x minus 0. If this limit exists, that means the function fx is differentiable at x equal to 0. Now calculate this limit. This equal to limit extends to 0. fx means we take actually, so this function, because here x tends to 0, so tends to 0 means not exact 0. So when x not exact 0, so when x exact 0, 2, but when x not exact 0, then function fx is, so this function, that means we put this value 2 minus 2x square minus x square sin 1 by x. Minus, what is the value of f0 when x equal to exact 0? f0 value is 2. Now calculate this limit. So here 2 cancel. So that means limit x tends to 0. Here just cancel out x. So this equal to minus 2x minus x sin 1 by x. Now we apply limit x tends to 0. This term 0 and this term x sin 1 by x. This term also 0. Why this limit 0? Here I actually write limit extends to 0, so this limit 0. But why this limit 0? Limit extends to 0, x sin 1 by x. Why this value equal to 0? Because here limit extends to 0, x sin 1 by x. So what is the rule? If any two sequence an into bn, two sequences multiply format, if one sequence is bounded or if one term is bounded and another sequence approaching to 0, so then the product is also approaching to 0. That means this tends to 0 when suppose the one sequence, suppose I let bn is bounded, means less than is equal to m, and an tends to 0, then overall the product format is also tends to 0. So here sin 1 by x is an bounded function, means its range between minus 1 to 1, so that means this is a bounded function. And when limit x tends to 0, so this x tends to 0. So here, so this term, so actually here, so this term so tends to 0 and this is bounded. So product of this overall function tends to 0. That's why limit x tends to 0, x sin 1 by x 0. So overall value is 0. So 0 means what? 0 means one finite value. So that means limit exists. 0 means we get one finite value. That means limit x tends to 0, this equal to 0. So that means, so 0 obviously exists, or more precisely this is a finite value. That means function is differentiable at x equal to 0. But here question says the function is not differentiable at x equal to 0. So that means wrong. Option A wrong. Okay. Now option B. Option B says that there is a positive real number delta such that f is decreasing on the interval 0, delta. Means there is a positive real number delta such that f is decreasing function on 0, infinity. So when we check the decreasing or increasing, that means first we, so derivative of the function. So what is the derivative of function? Derivative of f dash x is equal to, here the derivative is minus 4x and here minus 2x sin 1 by x and minus x square, sin derivative is cos 1 by x and cos derivative minus 1 by x square, that means this term plus and here x square cancel. So that means simply cos 1 by x when x not equal to 0. And so f dash 0 when x equal to 0, this function is 0. So now we check this function is decreasing on this interval 0 comma del. So decreasing means what? Suppose this is x-axis and this is y-axis. So the question says that there is a positive real number, means such there exists any positive real number delta, such that suppose there exists one delta. In 0 comma delta, in this interval, function is decreasing function. So decreasing function means in this interval function value, the throughout, the downside means the throughout the f dash value. So that means f dash x strictly less than 0 for all x belongs to 0 comma delta. Means there is such type of, so delta exists such that the f dash x so less than 0 for all x belongs to so 0 comma delta. But if we look very so carefully, when limit when limit, because when we put the near about value the extends to 0, means when we put the near value of 0, so that means when limit extends to 0, this whole term 0, this term 0 and this term 0. Now here only doubt what is the value of cos 1 by x. When we put the near values of x, this term 0 now only doubt what is the value of this. Now we only focus on what is the value of cos 1 by x, means when we approaching the near about value to 0, that means limit extends to 0 cos 1 by x. What is the behavior of this function? So limit extends to 0 means cos 1 by 0. So cos 1 by 0 means cos infinity. So what is the meaning of cos infinity? Cos infinity means, suppose this is x-axis and this is y-axis. So cos infinity, the graph of cos axis look like this. But when cos infinity means when x tends to infinity means, so there are so infinite way. Now what is the value of cos? Because actually I don't know. So why? Because the value of the cos x the oscillate between -1 to 1. Actually we don't know what is the value of cos infinity. So maybe 0, so maybe 1, or maybe -1, or the maybe half, or the maybe so -1 by √2. So that means limit extends to 0 cos 1 by x. This function is oscillate between -1 to 1. So but when we near about value of x tends to 0, this value is either positive, either negative, or 0. So that means we cannot say that. So there is any, if we take any small so delta, so this function not the throughout less than 0. So that means this function is not decreasing function, or more precisely this function is also not increasing function, because if we actually see the graph of cos 1 by x, so what is the graph of cos 1 by x? Cos 1 by x or sin 1 by x, what is the graph? So cos 1 by x means here is actually the oscillate, many oscillate type near about the 0, and this line is equal to y is equal to -1, and this line is equal to y is equal to 1. In near about the 0, cos x is oscillate. So that means, so there are the infinite values of x, such value, so cos x is the positive, and vice versa the value of cos x is negative. Means if we take the any small interval, so delta, and in this so 0 to so delta, this function the positive or negative both. So that means f dash x is not the strictly less than 0 or not the strictly or equal to greater than 0. So that means this f dash function is not monotonically increasing and not monotonically decreasing near about this 0. So that means option C is true. Option C what says? For any positive real number delta, the function is not increasing. This is obviously true, because if you take any small delta in this particular small interval, so delta, this cos 1 by x, this function oscillate infinitely many times. Oscillate infinitely many times means, so that means, so there are the infinite point of x near about 0, the function value is positive, and there are infinitely many points of x, this whole function value is negative. So that means when we say a function is monotonically increasing or decreasing, if the function is the f dash value is the strictly greater than 0 or strictly less than 0, but in this interval function is not strictly greater than 0, not strictly less than 0, means oscillate na. Similarly here also the sin 1 by x graph also the same graph. So that means this function is not increasing function. Okay. Now option D, x equal to 0 is a point of local minima. This is very easy. Now only check the local minima or local maxima. You can easily see the check by the graph. Local minima and local maxima. Okay, so actually we draw the rough graph of this fx. This is x-axis, this is y-axis. What is the value of 0? When x equal to 0, the function value is 2. Suppose this point is 0, 2. Okay, but when function is not equal to 0, so that means either positive or negative, the function value is whole. But if you look this whole function 2 minus 2x square minus x square sin by x, this whole function obviously less than 2 when x not equal to 0. 2 is strictly greater than this whole function, because here 2 minus this whole function is, this is negative, this is negative. So overall this 2 greater than of this number. So that means if we put x any non-zero value, this whole term less than 0. So that means when we put here x the positive side, the graph, so obviously here the downside. And similarly when here the negative side, graph obviously downside, not the more than 2. Okay, so this is the not the exact graph, this is actually the approximate graph for check this option D. Now question says the x equal to 0 is a point of local minima, but x equal to 0 point, this is not a local minima, so this point is a local maxima. So this option D is also false. Okay, okay friends, thank you.